Before we get started, are there questions over the homework?
No, but I do have a question about this. Why is there only 2 problems?
Because we're only doing 2.
That'll take like 10 minutes.
Ish. Welcome.
And we got a trade class Saturday, bro.
All right, guys. We're looking at the problem on the front. Yep, that's it. All right, guys. Let's focus in. Focus in.
I'm focused.
Square root of 2x equals the square root of x plus 7 minus 1. So we're solving this for the values of x, and there's a good chance we're going to have to check our solutions. So if we go through the steps, first step, is there one radical?
No.
2. If not, even them out. Well, we have 1 on each side. Now, if we said we had, say, 3, there's no good way to even those out. You're going to end up with 2 on one side, 1 on the other. If we had 4, we would want 2 and 2. If we had 5, 3 and 2, 2 and 3, we try to even it out as best we can. But the nice thing here is they are evened out. So that means we can put both sides to the its power, which for us would be 2. Now the left side of this is going to be kind of nice, because we have one term, and when we square it, the square root and square will cancel, giving us 2x. Now the other side, the right-hand side, we have 2 terms being subtracted. Because we have that addition or subtraction inside, we're going to have to multiply this out. We're going to have to distribute and multiply this through. So the first thing we're going to multiply is the square root of x plus 7 times the square root of x plus 7. Well, the way that we say that something's being multiplied by itself, we square it. So really we have the square root of x plus 7 squared. We'll finish the rest of that here in a second. But we know this square root and square will cancel, telling us that it is x plus 7. So that is the nice part of that one there. Next thing we have to do is multiply the square root of x plus 7 by negative 1, which tells us we have negative 1 times the square root of x plus 7. Or we can just say negative square root of x plus 7. Now we're going to do the same thing with our negative 1. Negative 1 times the square root of x plus 7. So that's just going to be negative square root of x plus 7. And lastly, negative 1 times negative 1 is plus 1. Questions on this so far? Now, if we look back at this, negative square root of x plus 7 and negative x square root of x plus 7, those are both the same radical, yes?
Yes.
So we can combine them. The first one, I have negative 1 of them, and I'm taking another 1 away, so we have, because negative 1 minus 1 is negative 2 square roots of x plus 7. So since they are the same radical, we can treat them like variables and add or subtract them. Almost done with this step here. We do have like terms here. 7 and 1 gives us 8. Finish combining like terms, because at this point there are no other like terms. Because the only other place x appears on that right-hand side is outside and inside the radicals. We can't combine those. The 8 and negative 2 are not, we can't combine them because it's really negative 2 times that radical. So questions on how we got to this here? All right. You ready to do our next step, which we have pretty much been ignoring up to this point. Step number 3. Are there any radicals left? Yes. If so, repeats steps 1 and 2. So if we get finished with squaring, putting it to the nth power, and there's still radicals left, we go back to step number 1. Step number 1, is there one radical? If so, get it by itself. So there's 2 things we can move first. What do we want to do first? The x, we can minus x from both sides. And 2x minus x is 1x. Here x minus x simplifies out, leaving us with x is equal to 8 minus 2 square root of x plus 7. Next thing we can do is subtract 8, telling us that we have x minus 8 is equal to negative 2 square root of x plus 7. Is the radical by itself? No, we need to divide both sides by negative 2. Telling us x minus 8 over negative 2 is equal to the square root of x plus 7. Now is the radical by itself. All right, now we can move on to step 2. We're going to put both sides to the nth power. Well, the nth power in our case is what? 2. First time we did this, we looked at the left side. I'm going to look at the right side first. Here we only have one term, and that square and that square root are going to cancel, telling me that the right-hand side is nicely x plus 7. All right. Now, the left-hand side, as long as we don't have addition or subtraction in the top or bottom of this fraction, we can just square the top and square the bottom. I do see subtraction. So what that means is we're going to have to actually multiply the thing by itself. So our x minus 8 over negative 2 is going to have to be multiplied by x minus 8 over negative 2. Well, of the 2 multiplications we're going to do here, I'm going to do the denominators first. Because when we multiply 2 fractions, we multiply numerator with numerator, denominator with denominator, top with top, bottom with bottom. If we look at the bottoms, they're both what? And negative 2, yes? Negative 2 times negative 2 is what? 4. Negative times a negative is a positive. 2 times 2 is 4. That's why I started there, because that's nice. If we look at the numerators, we have to multiply the x minus 8 with x minus 8. And like we did above, we're distributing out. X times x is x squared. X times negative 8 is negative 8x. We'll switch colors. Negative 8 times x is negative 8x. And negative 8 times negative 8 is plus 64. Okay. We combine like terms, negative 8 and negative 8 does give us negative 16x. Now the question is, are there any radicals left? No. Because if there were, we go back to step 1 and do this all over again. Because we keep repeating this process till all the radicals are gone. All the radicals are gone, so we can move on to step number 4 and solve. Now, at this point here, it's not too bad except for the fact that the left-hand side is being divided by 4. what would be really nice is if I could come over here and say multiply this by 4. Now, why would that be nice? Because it's being divided by 4, yes? So if I multiply it by 4, that multiplication of 4 and that division of 4 would cancel out, leaving us with x squared minus 16x plus 64. But we can't just multiply one side by 4. We got to multiply the other side by 4. Because this is an actual step, an actual solving process, because if we scale it up by a factor of 4, it gets rid of the fraction on one side, and it just makes the other side match it. 4 times x is 4x. 4 times 7 is 28. And you can do this with any type of equation. If you have decimals throughout a quadratic, these higher degree polynomials, multiply them by a factor of 10, 10 to a power, enough to get the decimals to go away. Because now this is something that we know how to solve. Now we just need to get this equation equal to 0. So what can we do first? Minus 4x. So we'd have x squared. Not killer, I wanted x squared. Minus 20x plus 64 is equal to 28. Subtract 28 from both sides, telling us x squared minus 20x plus 36 is equal to 0. Do we want to graph or factor? Factor, graph, we'll do both. So if signs that will be nice to graph is if the number in front of x squared is 1, or if that number in front of it is a greatest common factor across all 3 terms. Then we know we won't have fractions. Now, I'm just going to throw in a number, let's say 3. 3 is not a greatest common factor across all 3, so if this was the setup, it's not. There would be a fractional answer. We would have to factor. But here, it's going to work out. Now, factoring, since the third term's positive, signs are the same and match the sign of the middle term, negative and negative. Factors of our first term, x squared, well, there's only one set. X and x, the number in front of it's 1, so we just have x and x. 36 does not have one set of factors. We have 1 and 36, 2 and 18, 3 and 12, 4 and 9. 5 doesn't work, but 6 and 6 does. What set of factors do we want? 2 and 18. And those indeed are the correct factors. Telling us that we have x minus 2 times x minus 18 equals 0. If we have two things multiplied together equals 0, one of them has to be 0. Solve. So x minus 2, add 2, telling us x is 2. X minus 18, we'd add 18. Telling us that our solutions are 2 and 18. Questions on how we got 2 and 18? We're ready to check this. Now, I'm going to do something that's very nice for this here. And just erase it all so I can write underneath it. So we can check 2 first. Yeah. As much as sometimes I wish I could do that on a piece of paper, I know I'd accidentally hit it and erase everything. So if we check 2 first, on the left-hand side we have 2 times 2, which is 4. Square root of 4 is 2. Let's look on the right-hand side. 2 plus 7 is 9. Square root of 9 is 3. 3 minus 1 is 2. 2 is indeed equal to 2. So it tells us that x equals 2 is one of our solutions. We can do the same thing with 18. Two times 18 is 36. Square root of 36 is 6. 18 plus 7 is 25. Square root of 25 is 5. 5 minus 1 is 1. So the only solution that we have for this here is that x is equal to 2. Questions on this here? It's a lot. It is a lot of steps. What would we say? Would you all say that that additional step where that step 3 has to come into play is harder than what we were doing? It's not harder, it's just more steps. That's really all it is. And it seems, especially if you saw that in August, probably thought that was the worst thing on the planet, never be able to do it. But yeah, it is doable. It's just a lot of steps, especially taking it one step at a time. So we have the problem on the back. That's it for today. I did, if you want to, you can do the problem on the back. It is a bonus 10 points, 10-point assignment. Yes, sir. It is going to be next Tuesday, Wednesday.